Hello, 8th grade math students. Mr. Lawrence here, and unfortunately I'm going to see the doctor about my back. Well, I mean, I guess that's a fortunate thing, but I'm not able to be with you. But we must press on. Some of you need some serious grades with the upcoming test next week, probably Tuesday of next week, possibly Thursday. All right, you might want to write that down because remember, the DC trip is riding on you being there. Now, many of you have not taken advantage of me of trying to improve your grade from the previous test. You're running out of time. And with me being injured and not being able to be there, you're losing more time. So please, as soon as you know I'm there, you better get in for help, because if you don't do something about your grade, no fairy godmother is going to come in and save you. It doesn't work that way. You have to take a mature approach and improve your grade with the opportunities given. Just doing old homeworks will not fix the problem. All right. So we're going to be in digits here. You should be listening to this video. You should be pausing it as you go. I'm going to put up a little tutorial because there is a graphing feature that you need to know about in digits, and you may not have seen that yet. So I'm going to start this video. This is going to take about 2 minutes and 52 seconds, so you just need to watch and pay attention to it, okay? And then we'll see how to use it as we get into some problems. So here we go.
In this video, you will learn about the full plane mode of the coordinate grapher tool. You can use the full plane mode to plot points, lines, and inequalities in the coordinate plane. To plot a point on the graph, click on the Point button and then click on the coordinate plane where you want to place the point. As long as the Point button is enabled, clicking on the coordinate plane will add points to it. When you are done adding points to the coordinate plane, click on the Point button again to disable it. Note that a maximum of 10 points can be plotted on the graph. You can remove a point by clicking the Erase button and then clicking on the point you want to remove. Click on the Erase button again to disable the Erase feature. If you want to undo your changes, click the Undo button. If you want to redo the changes, click the Redo button. You can show the coordinates of a point by clicking on the point and selecting the Show Coordinates option. If you want to show the coordinates of just this point, click the X button to exit the menu. If you want to show the coordinates of all the points on the graph, select the Apply to All Points button. You can adjust the location of a point by dragging it. To hide the coordinates, click on a point and deselect the Show Coordinates checkbox. Click on Apply to All Points to hide the coordinates of all the points on the graph. To graph a line, first click on the Line button. Then, click down on the coordinate plane and drag in the direction that you want to draw the line. A line will appear with 2 reference points attached to it. Notice that the line has a label showing its name. You can drag the reference points to the locations you want. When you are done graphing lines, make sure to click on the Line button again to disable it. Note that a maximum of 5 lines can be drawn on the graph. To check the location of the line's reference points, click on the line and select the Show Coordinates option. To examine the slope of the line, click on the line and select the Show Rise and Run option. Notice that the Rise and Run lines appear. While the Show Rise and Run option is selected, the slope of the line becomes fixed, so that dragging either reference point will move the point along the line. You can also move the line itself by dragging it. To hide the Rise and Run lines, deselect the Show Rise and Run option.
Okay, so that's pretty useful, and I don't know if you noticed it, but when it does the rise and run, they don't actually tell you the slope. They just tell you the rise is 7 and the run is 7. You'll still have to set up the ratio or the fraction and simplify it if possible. The slope of this line is 1, and then if you look, when they moved it, look, you're going to have a rise of 11 and 2/10 and then negative 11 and 2/10. I'm sorry, I said the rise was 1, it was -1. It's going to be -1 in this case as well. All right, so that tool is going to be showing up in your homework. assignments now. You'll be able to use it to help you graph. All right, this one says graph the equation y equals x plus 3. What is the y-intercept of the graph? Well, first of all, you need to know what a y-intercept is, okay? A y-intercept is the place the line crosses the y-axis. The y-intercept, that's the place where the line, sorry, that doesn't look very good. Let me try right. I'm using my airliner. It's just not looking good. I'm going to define a y-intercept. Oops, that's not a y. Y-intercept. Okay, that is going to be the place. I don't know why I'm in erase mode. There we go. Y-intercept. The definition, the place or point where the line crosses the y-axis. You might be wondering, is there such a thing as an x-intercept? There is, and that would be the place or point where the line crosses the x-axis. The reason we talk about the y-intercept is because when we are in this special form of a linear equation where it says y equals mx plus b, this special form is called slope-intercept form. Slope and then intercept form. Slope-intercept. And the reason we call it that, when you're in this form, the slope is sitting here in x's position. This is the slope. Okay? The y-intercept is actually sitting here with its sign, y-intercept. Okay? Now, if I gave you an equation like, say, y equals negative 2x plus 5. To graph it before today's lesson, you would have had to make an input-output table, choose 3 x's or 2 minimum. Okay, and a lot of you would have picked 1, 2, and 3. I wouldn't do that. My algebra kids do that all the time. Drives me nuts. I don't pick 1, 2, and 3. I might pick negative 1, 0, and positive 1. And when I do my math, let's see, when I put 1 in here, I get negative 2 times 1 is negative 2. See what I'm doing? I'm doing negative 2 times 1 plus 5. That's what I'm doing to figure out what the y-axis is going to be, or the y-coordinate. That's going to get me a 3. To get this, when x is 0, I'm going to substitute 0 in for x. It looks like I'm going to get 5. And then negative 1 substituted in for x. And that's going to get me 7. Okay? Then you would have plotted those 3 points. But do you notice something? When you're in slope-intercept form, when the y is alone, this here is the y-intercept. This is the y-intercept. I can graph so much easier now. Watch this. Watch this. What was the equation? I'm in highlight mode. Silly Mr. Lawrence. Y equals negative 2x plus 5, right? Let me get a piece of graph paper out here. Okay. So I need to get a little more room for my graph. Oops, I'm in draw mode. That's no good. All right, I better lock him in place, and I better erase that stray mark. All right, we said the 3 points that I would get were what? Negative 1, 7, 0, 5, and 1, 3. So let me plot some points there. So negative 1, 7, let's see, 9, 8, 7 is going to be there. 0, 5 should be here. This is the x-axis and the y-axis, right? And then 1, 3 should be there. Well, if you look, my line is going to be going like this. Okay? Make it nice and long. Make sure I put both arrowheads on, because the line goes forever in both directions. All right? And so it might look something like that. The point 0, 5 is on the line. My slope, and I'm going to start using m for slope, you'll see that, was negative 2 as a fraction. It's negative 2 over 1. Watch this. From here, I could go down 1, 2, and then right 1. And sure enough, I hit the line. If I'd gone up 2 and left 1, that would be a positive 2 and a negative 1. I hit the line again. My point in telling you this is, when y is alone, you know the slope and the y-intercept. Watch how simple this is to graph. Okay, let me put like this. Get a sheet of graph paper. Yeah, I think I'm going to use this one this time. Ooh, that's pretty. There's a pretty sheet of graph paper right there. Okay, let me lock that in place. Now, I'm telling you, I know the y-intercept. The y-intercept is -4. So the point 0, -4 is going to be on this graph. 1, 2, 3, 4. There you go. 0, -4. And the slope is 3, or 3 over 1. So watch, from here, I'm going to count 3 over 1. Okay, up 3 over 1. Let me see, infinitely cloner, all right? So 1, 2, 3, and 1. There is a second point on that line. I can continue to do this because the slope has to be the same throughout the line. 1, 2, 3, and over 1. I could change both signs and count down 3 and then to the left 1. And oops, I lost my point, I think because it was underneath the graph. I can't seem to get that to scroll. I'll scroll it by hand. Oop, that's a little too much, Mr. Lawrence. Take it easy on your scrolling there. All right, so I could count down 1, 2, 3, and then back 1, and sure enough, I'm getting the line. And there we go. Okay, so we're in slope-intercept form. We can tell the slope and the y-intercept just by looking at the equation. All right, just by looking at the equation. So let me see. Let me go back into digits here and see what their next example is. And all right. Oh, this one, they want to know the y-intercept of the line y equals x plus 6. Well, guess what? It's the point 0, 6. Yeah, look, dun, da, 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 6. It's the point 0, 6. It's on the y-axis. They want me to graph y equals x plus 3. All right, let me get my graphing tool opening up here. Hopefully it works. All right, there we go. I know it's y equals x plus 3. I get my point mode, so you click the point. I know 3 is a y-intercept right there. And then from here, oh no, I better get another point. My slope was x plus 3. My slope was rise 1. Run 1, I get another point right there, and then if I draw this line, I can go 1, oh, maybe I'm not doing this right. Let me get rid of those points, show you how to use the tool. Okay, let me just go right to the line. The y-intercept is at 3, this is a point 0.03, and it's not working. That's why I'm having trouble. So let me try this again. I'll put it at 3, okay, and then click there. Okay, and it apparently I cannot get this to work. So 1, 2, 3, and then down 1. Yeah, it's not working for some reason. Okay, so I'm not sure really what's going on here. So it should work for you though. Maybe if I just try to do it on this. Let me try it on here. Nope, it goes to that blow up and it doesn't work. Okay, it will work for you though. I don't remember students complaining that it doesn't work for them. It's just in that example. So let's go down to part 2 of this section. And it's loading, it's loading, it's loading. Oh boy, this is so much fun watching. Oh, there we go. Okay, for each graph, or the graph of each equation, find the y-intercept. So let's take a look at A. All right, here's the line. The blue thing is the line with the arrowheads, and it's going through -2. So the y-intercept is -2. Remember, the y-intercept is found on the y-axis. So I just went to where they meet each other, right there. Okay, B, the y-intercept, looks like it's +2 this time. Okay, on here I can find the y-intercept without graphing. It's -3. Is that number added or subtracted to the x? And then, of course, this one is +3. By the way, looking at C and D, I can tell, oh my gosh, what the hookah waka was that? That's pretty ugly. All right, I can tell the slope just by looking at the coefficient of x, the 4. So it'd be 4 over 1 would be my slope. So if I was graphing this one, I'd plot y equals -3, 0, -3, and then I would rise 4, run 1, rise 4, run 1, and that would draw my line. On this one, I would plot the point 3, 0, 3 on the y-axis. And then I go down 4 and right 1, down 4 and right 1. All right, very good. Pretty easy stuff. Okay, what is the y-intercept of the graph of the equation? Dun, dun, dun. It says y equals negative 5x minus 1. Y-intercept, you guessed it, negative 1. Man, this is getting hard. I don't know if you guys can do it. Okay, your friend says that the graph of every linear equation must cross the y-axis. Provide a counterexample. In other words, can you draw me a line that does not cross the y-axis? All right, that should be pretty easy. See if you can do that. Go ahead and pause the video. All right, and here we go. We have a vertical line. It's parallel to the y-axis, therefore it does not cross it. We'll talk more about why its equation is x equals 3. It's kind of a cool thing in math. All right, last section here, 5.3. Let's see what they have in store for us. All right, it says the line models the total amount of snow on the ground during a snowstorm. What is the y-intercept of the line? What does the y-intercept represent? What is the slope of the line? What does it represent? All right, well, let's see. Oh no, it's snowing. Such high quality animation. Ooh, it's building a graph of snow. Wow, if only I could have the snow build me a house that way. That'd be pretty cool. Okay, so down here is our time in hours, going from 0, the start of the snowstorm, and 1, 2, 3, 4, 5, 6, 7, 8, 9 hours. Along the vertical side, we have the height in inches. And so there was 3 inches of snow on the ground at the start of the storm. See how this time is 0. And then after 2 hours of snowing, it's been up to 4 inches. After 4 hours, it's up to 5. After 6 hours, it's up to 6, and so on. No, this is not enough to get you a snow day because the 3 inches on the ground wouldn't be on the road to start with. And an inch every 2 hours is plenty of time for the crews to get the roads clear. Though, when the storm is done, it might be fun to play in. Looks like we're going to get up to 8 inches of snow. All right? So, what is the y-intercept? Well, the y-intercept is this point right here, right? On the y-axis. It represents, and if you were listening, you heard this already, the amount of snow on the ground at the start of the storm. Yeah, there was already 3 inches of snow on the ground when the storm started. How do I know it's when the storm started? Because the time is 0. At 0 hours, the storm is just beginning to start. There's already 3 inches of snow from a previous snowstorm. Okay? What is the slope of the line? Well, let's see. We're rising 1 inch of snow and running 2 hours. So the rise of the slope of the line is 1 inch every 2 hours. Here the rate, kind of like 30 miles per hour. This is 1 inch per 2 hours. Okay? And it represents the rate at which it's snowing. Slope always represents a rate. Okay, 1 inch every 2 hours, 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 1 inch every 2 hours. There you go. All right, this one says a bottle of dish soap starts to leak. Maybe there's a hole in the bottom of the bottle. The line models the total amount of dish soap in the bottle. Okay, what is the y-intercept? Well, let's see. Here we have the hours, and here we have the fluid ounces of dish soap. So the y-intercept is here, right? At 0 hours, there's 6 ounces of dish soap in the bottle. What's happening to the amount of soap? Well, it's going down, of course, right? The 0.6, the y-intercept of 6, represents the amount of ounces in the bottle before it started to leak. Okay? What does the y-intercept represent? We just told you. Now, let's check the slope out, though, too. Let's see. It looks like I lost 1 ounce for every 1 hour. Oops, did you see that? I just made a mistake. It did lose 1 ounce, but this is 1 space, but this is not 1 hour. This is 3 hours. So it's losing 1 ounce every 3 hours. So it's leaking out fairly slowly, and it might not get noticed right away. That's the slope. It's leaking out 1 ounce every 3 hours, another ounce every 3 hours, another ounce every 3 hours, and that's the rate. All right. That's it for the video, ladies and gentlemen. If you need to rewatch part of it, that's fine. If you need help with the graphing tool, please feel free to ask the sub, show them the part of the video and see if they can help you, or perhaps a classmate. All right, Mr. Lawrence signing off. Have a good night, everybody.